Hi everyone. So we are going to jump into our second section of this unit. So this is going to be section 7.02, truth tables. So yesterday we talked about our logical connectives, and so we're going to build a truth table for each of those logical connectives. So let's start with the not. So for here we have not, we use this symbol, so not P. I'm always going to start with whatever letters I'm going to use. So here I have P is my proposition, so I'm going to start with P as my first column. If I were to have Q, I would also have a column for Q, but we only have P. And then I'm going to make a column for not P. So the way that we start here, making our truth table on the P column, we always start with the first half true and the second half false. So we're only going to have two values here. So the first one's going to be true and the second one is going to be false. So if my statement is true, the original P is true, then not P would be false. And similarly, if I start with P being false, then not P, not false, would be true. So this is my truth table for not P. Now if I want to build a truth table for and, well, then I'm going to need two propositions. So we're going to have P and Q. And that's going to look like 4 rows in my column. Since I'm having two propositions, I need to start with P and then Q, and then whatever my logical connective is at the end, so P and Q. So I'm going to have 4 rows in my column, and this is going to be, again, the first half is going to start with true for P. So the first half will be true. Then, sorry, this stylus is acting up. Okay, so the first half is true, and then the second half is false. And then for Q, the first quarter will be true, and then after that we go from true to false, alternating each quarter. So there's only 4 here, so the first quarter is just going to be the first box here, and then we just alternate true, false, true, false. And the point of this is to get every possible combination of true and false with P and Q. So here, now that I have and, well, in order for and to our final statement to be true, everything has to be true. So if I have true and true, then that is a true statement. If I have true and false, then that's false, because both statements have to be true in order for the whole statement to be true. So I have false and true, that is also false, and then false and false is false. So now, looking at just regular OR, so we have P or Q. Again, we start with P and Q. So I'm going to have a column for P, a column for Q, and then P or Q. So again, the first half of P will be true, second half will be false, and then a quarter of Q will be true, and then keep going. I'm saying it like this because in case we get to 3 propositions in our statement, then we're going to exponentiate how many rows we have. So that's why I'm saying it like this. So for an OR statement, the only time that OR is true is if one of the statements are true. So if I have true or true, one of those is true, so then the whole thing is true. If I have true or false, then again, that meets our criteria. At least one of them is true, so the whole statement is true. Similarly with false or true. And then lastly, if I have false or false, well, those both are false. So the whole thing is false. So that's for or. Now let's take a look at when we have exclusive or. And so again, that's the or with the line underneath it. And so, of course, we start off the same way. We're going to have our P and our Q. So true, true, false, false, true, false, true, false. And so for exclusive or, this is going to be when one of the statements is true, but not both. So we can't have, let's say in the first line here, how we have true or true, well, that's going to be a false statement because they both can't be true. So it's one or the other, but not both. So if both statements are true, then the whole statement is false. So looking at the next one, if we have true or false, but not both, that meets our criteria because one of them is true, but not both of them. So that is true. And then this follows the same structure, false or true. One of them is true, but not both. And then lastly, if both statements are false, then the whole statement is false. So that is for exclusive or. So now we'll do if and only if, and then if then.